deserts of the world. Part 1. What is a desert? Imagine standing in a place where rain may not fall for years. A landscape where the horizon stretches endlessly beneath an open sky, where scorching heat dominates the day, freezing temperatures arrive at night, and life survives against extraordinary odds. When most people hear the word desert, they imagine endless sand dunes beneath an unforgiving sun. While this image certainly represents some deserts, it tells only part of the story. In reality, deserts are among the most diverse environments on Earth. Some are covered by golden dunes that rise like waves across the landscape. Others consist of rocky plateaus, gravel plains, or vast salt flats. Some deserts are colder than any place, inhabited by humans, while others experience some of the highest temperatures ever recorded. The largest desert on Earth is not located in Africa. It is Antarctica. This surprising fact reminds us that deserts are not defined by temperature. They are defined by one simple characteristic: a lack of precipitation. Scientifically, a desert is generally defined as a region receiving less than approximately 250 millimeters, or about 10 inches, of precipitation each year. Some deserts receive far less. The Atacama Desert in northern Chile contains areas where measurable rainfall has not been recorded for decades. In contrast, certain parts of Antarctica receive less precipitation than the Sahara Desert, making them even drier despite being permanently covered by ice. This definition may seem straightforward, yet the processes that create deserts are remarkably complex. Earth's deserts are products of atmospheric circulation, geography, ocean currents, mountain ranges, and climate patterns that have evolved over millions of years. To understand deserts, we must first understand our planet's atmosphere. Every day, the sun heats Earth's surface unevenly. Warm air near the equator rises into the atmosphere, carrying moisture upward. As this air rises, it cools. Water vapor condenses into clouds, producing the heavy rainfall that nourishes tropical rainforests. After releasing much of its moisture, the now dry air moves toward higher latitudes. Around 30 degrees north and south of the equator, this air begins to descend. Descending air becomes warmer and drier. Cloud formation becomes increasingly difficult. Rain becomes rare. These regions are dominated by persistent high-pressure systems that suppress precipitation throughout much of the year. Many of the world's great hot deserts, including the Sahara, Arabian, Kalahari, Australian, and Sonoran deserts, exist within these global atmospheric circulation zones. Ocean currents also play a crucial role. Cold ocean currents flowing along western continental coastlines cool the air above them. Cool air contains less moisture. As a result, clouds struggle to develop, and rainfall becomes extremely limited. This process explains the existence of remarkably dry coastal deserts, such as the Atacama Desert of South America and the Namib Desert of southwestern Africa. Despite their proximity to the ocean, these deserts receive almost no rainfall. Instead, moisture often arrives in the form of dense fog. Many desert organisms have evolved to harvest water directly from this fog, demonstrating one of nature's most remarkable survival strategies. Mountains create deserts as well. When moist air encounters a mountain range, it is forced upward. As the air rises, it cools and releases precipitation on the windward side. By the time it reaches the opposite slope, much of its moisture has already been lost. The descending air becomes warmer and drier, creating what scientists call a rain shadow. Some of Earth's great deserts owe their existence to this phenomenon. The Gobi Desert of Mongolia and northern China lies partially within the rain shadow created by the Himalayas and the Tibetan Plateau. Similarly, parts of the Great Basin Desert in North America formed behind the Sierra Nevada mountain range. Not all deserts are hot. This is one of the most widespread misconceptions. In fact, the two largest deserts on Earth are polar deserts. Antarctica covers approximately 14 million square kilometers, making it by far the largest desert on the planet. The Arctic polar desert ranks second. Although these frozen landscapes are covered with snow and ice, they receive remarkably little precipitation. The air is extremely cold and contains very little moisture. As a result, snowfall remains surprisingly limited throughout much of the year. Hot deserts and cold deserts differ dramatically in appearance, yet they share the same defining characteristic. Both are exceptionally dry. Deserts occupy approximately 1/3 of Earth's land surface. Far from being lifeless wastelands, they support an extraordinary variety of ecosystems. Plants, animals, fungi, and microorganisms have developed remarkable adaptations that allow them to survive conditions once thought impossible. Some plants store water within thick stems and leaves. Others produce seeds capable of remaining dormant for years until rainfall finally arrives. Many animals avoid daytime heat by becoming nocturnal, emerging only after sunset when temperatures fall dramatically. Camels can tolerate significant dehydration. Fennec foxes use their oversized ears to release excess body heat. Certain desert beetles collect moisture directly from fog droplets. Even microscopic organisms thrive within rocks, protected from intense sunlight, while drawing moisture from the surrounding air. Life persists because evolution rewards adaptation. Deserts also preserve history. Dry conditions dramatically slow the decomposition of organic materials. Ancient human settlements, prehistoric footprints, fossils, cave paintings, and archaeological remains often survive in deserts far longer than they would in humid environments. The deserts of Egypt preserved thousands of years of written history on papyrus. The Taklamakan Desert safeguarded lost cities along the Silk Road. The Atacama Desert has yielded exceptionally well-preserved mummies dating back thousands of years. These landscapes function as natural archives of human civilization. Yet deserts are not static. Wind constantly reshapes dunes. Flash floods carve new channels through dry valleys. Salt lakes appear and disappear. Sand migrates across entire regions over decades and centuries. What appears timeless is, in reality, constantly changing. Modern science has transformed our understanding of these extraordinary environments. Satellite observations now allow researchers to monitor shifting dunes, vegetation growth, groundwater changes, and desert expansion with remarkable precision. Climate scientists study deserts to better understand Earth's atmospheric circulation. Planetary scientists examine desert landscapes because many closely resemble the surfaces of Mars. NASA and the European Space Agency frequently conduct rover testing in deserts before launching missions into space. In many ways, deserts provide natural laboratories for exploring both Earth's past and humanity's future. Yet despite centuries of exploration, much of the world's deserts remain surprisingly mysterious. Beneath their sands lie ancient rivers, forgotten civilizations, fossil ecosystems, underground aquifers, and geological records stretching back hundreds of millions of years. These seemingly empty landscapes continue to reveal new discoveries every year.
Part 2. Earth's Greatest Deserts. At first glance, deserts may appear empty and lifeless. Yet each desert tells a unique geological story shaped over millions of years by climate, tectonic forces, wind, water, and time. Together, these extraordinary landscapes cover nearly 1/3 of Earth's land surface, making deserts one of the planet's largest terrestrial biomes. Although the Sahara is often considered the world's largest desert, this common belief is incorrect. The largest desert on Earth is Antarctica. Covering approximately 14 million square kilometers, Antarctica is almost 1.5 times larger than the United States. Despite being covered by ice up to 4 kilometers thick, Antarctica qualifies as a desert because it receives remarkably little precipitation. In many inland regions, annual snowfall is equivalent to less than 50 millimeters of water. Temperatures can fall below -80 degrees Celsius, making Antarctica not only the largest desert on Earth, but also the coldest. Life here has adapted in extraordinary ways. Tiny microorganisms survive within the ice itself: penguins, seals, and seabirds. depend almost entirely on the surrounding Southern Ocean rather than the frozen interior. For scientists, Antarctica serves as one of the world's most important natural laboratories, preserving climate records within ice cores that extend back hundreds of thousands of years. These frozen archives help researchers understand past climate changes and predict future environmental trends. North of Antarctica lies the second-largest desert on Earth, the Arctic Polar Desert. Stretching across Greenland, northern Canada, Alaska, and parts of Russia, this immense frozen region experiences similarly low levels of precipitation. Although snowfall occurs, the extremely cold air contains little moisture. The Arctic supports remarkable wildlife, including polar bears, Arctic foxes, musk oxen, snowy owls, and reindeer. Unlike Antarctica, however, the Arctic is home to indigenous peoples who have successfully adapted to these harsh environments for thousands of years. Leaving the frozen deserts behind, we arrive at the world's largest hot desert, the Sahara. Spanning approximately 9.2 million square kilometers, the Sahara stretches across 11 African countries, from the Atlantic Ocean in the west to the Red Sea in the east. Its immense size rivals that of the United States. Yet, contrary to popular imagery, sand dunes occupy only about 20% of the Sahara. The majority consists of rocky plateaus, gravel plains, dry valleys known as wadis, volcanic mountains, and ancient riverbeds. Some regions receive less than 25 millimeters of rainfall annually, while others may experience years without measurable rain. Daytime temperatures during summer frequently exceed 45 degrees Celsius, and the highest ground temperatures can rise even further. At night, however, temperatures may drop dramatically due to the dry atmosphere's inability to retain heat. Despite these extreme conditions, the Sahara supports an astonishing diversity of life. Fennec foxes, addax antelopes, desert hedgehogs, monitor lizards, horned vipers, and countless insects have evolved remarkable physiological adaptations to survive. Scattered throughout the desert, oases provide fresh water, allowing human settlements to flourish for thousands of years. Ancient caravan routes once crossed the Sahara, connecting North Africa with sub-Saharan civilizations through trade in gold, salt, ivory, and textiles. To the east of the Sahara lies another vast expanse of arid land, the Arabian Desert. Covering approximately 2.3 million square kilometers, it spans much of the Arabian Peninsula, including Saudi Arabia, Oman, the United Arab Emirates, Yemen, Jordan, and Iraq. Within this immense desert lies the Rub al-Khali, or the Empty Quarter. It is the world's largest continuous sand desert. Some dunes rise more than 250 meters high, constantly reshaped by powerful winds. Rainfall remains extremely scarce, often below 35 millimeters per year. Yet beneath these sands lie enormous reserves of groundwater and some of the world's largest petroleum deposits, resources that have profoundly influenced modern history. Moving eastward into Central Asia, the landscape changes dramatically. The Gobi Desert extends across southern Mongolia and northern China, covering approximately 1.3 million square kilometers. Unlike the Sahara, the Gobi is a cold desert. Winters are severe, with temperatures falling below minus 40 degrees Celsius, while summers can exceed 40 degrees Celsius. This enormous annual temperature variation makes the Gobi one of Earth's most climatically extreme environments. Its landscape consists primarily of exposed rock, gravel plains, and sparse vegetation rather than towering sand dunes. The Gobi has become internationally famous for its paleontological discoveries. In the 1920s, expeditions led by the American Museum of Natural History uncovered some of the world's first scientifically documented dinosaur eggs. Since then, numerous fossils of dinosaurs, mammals, and prehistoric reptiles have transformed our understanding of ancient ecosystems. On the western coast of South America lies one of the most extraordinary deserts on Earth, the Atacama Desert. Located primarily in northern Chile, the Atacama is widely recognized as the driest non-polar desert in the world. Some weather stations have recorded no measurable rainfall for decades. Scientists estimate that certain regions have remained exceptionally dry for millions of years. This extreme, Aridity results from a combination of factors. The cold Humboldt Current suppresses cloud formation along the Pacific coast. The towering Andes Mountains block moisture arriving from the east. Persistent high-pressure systems further inhibit rainfall. Despite these conditions, life persists. Microorganisms inhabit salt flats. Specialized plants survive by collecting fog moisture. Flamingos gather around mineral-rich lagoons. Astronomers have also found the Atacama uniquely valuable. Its exceptionally dry atmosphere, minimal cloud cover, and high elevation create some of the clearest skies on Earth. Today, the Atacama hosts world-class observatories, including the Atacama Large Millimeter/Submillimeter Array, better known as ALMA, which allows scientists to study distant galaxies and the origins of the universe. Along Africa's southwestern coast lies another remarkable desert, the Namib Desert. Estimated to be at least 55 million years old, it is considered one of the oldest deserts on Earth. Unlike many deserts, the Namib receives frequent coastal fog generated by the cold Benguela Current. Many organisms depend entirely upon this moisture. The Namib desert beetle has evolved a remarkable technique for survival. By climbing dunes during the early morning and positioning its body at a precise angle, it collects tiny droplets of fog that flow directly toward its mouth. This extraordinary adaptation has even inspired modern engineers developing water harvesting technologies for arid regions. Towering red sand dunes dominate much of the Namib. Some exceed 300 meters in height, making them among the tallest dunes on Earth. Farther south, another immense arid landscape stretches across Argentina. The Patagonian Desert covers approximately 670,000 square kilometers, making it the largest desert in South America. Unlike tropical deserts, Patagonia experiences cool temperatures, powerful winds, and relatively low rainfall created by the rain shadow of the Andes Mountains. Its unique wildlife includes guanacos, rays, pumas, armadillos, and numerous endemic bird species adapted to open grasslands and rocky plains. Finally, we travel to Australia, the driest inhabited continent on Earth. Rather than containing one enormous desert, Australia hosts several interconnected desert regions, including the Great Victoria Desert, the Great Sandy Desert, the Simpson Desert, and the Gibson Desert. Together, these landscapes cover nearly 1/5 of the Australian continent. Many people imagine Australian deserts as barren wastelands. In reality, they support remarkable biodiversity. Marsupials, reptiles, birds, insects, and countless plant species have evolved to survive prolonged drought and intense heat. For tens of thousands of years, Aboriginal Australians have successfully lived within these deserts, developing profound ecological knowledge that continues to inform modern conservation science. From the frozen silence of Antarctica to the blazing sands of the Sahara, from the fossil-rich Gobi to the ancient dunes of Namibia, each desert reveals a different chapter in Earth's geological history. Though separated by thousands of kilometers and shaped by different climates, they all share one defining characteristic: they teach us that life is remarkably resilient. Even in the harshest environments on Earth, nature finds a way to survive. But deserts are not isolated from the rest of the planet. Today, they are changing. Climate change, expanding human populations, unsustainable land use, and desertification are reshaping many arid regions faster than ever before.
The future of Earth's deserts. For thousands of years, deserts have challenged explorers, inspired civilizations, and shaped the evolution of life itself. What once appeared to be empty wastelands are now recognized as some of the most scientifically valuable ecosystems on Earth. Deserts preserve Earth's geological history. They record ancient climates. They protect archaeological treasures. They reveal how life adapts to extreme environments. And increasingly, they help scientists understand the future of our changing planet. One of the greatest misconceptions about deserts is that they are expanding simply because of global warming. The reality is far more complex. Deserts naturally change over time. Throughout Earth's history, shifting climates have caused deserts to expand and contract over thousands of years. The Sahara itself tells an Extraordinary story. Around 10,000 to 5,000 years ago, much of what is now the Sahara Desert was covered by grasslands, rivers, and lakes. This period, often called the African Humid Period, supported elephants, giraffes, crocodiles, hippos, and thriving human communities. Ancient rock art discovered across the Sahara depicts people fishing, hunting, and herding cattle in landscapes that today receive almost no rainfall. These dramatic environmental changes were driven primarily by long-term variations in Earth's orbit and the strength of the African monsoon. As rainfall gradually declined, vegetation disappeared, lakes dried up, and the modern Sahara emerged. Today, however, human activity is accelerating environmental change in many dry regions. Scientists distinguish between deserts and desertification. A desert is a natural ecosystem. Desertification is the degradation of fertile land caused by a combination of climate variability and unsustainable human activities. Overgrazing, deforestation, poor agricultural practices, excessive groundwater extraction, and rising temperatures can all reduce vegetation cover. Without plants to stabilize the soil, wind and water erosion become increasingly severe. Eventually, once productive landscapes may lose much of their biological productivity. According to the United Nations Convention to Combat Desertification, billions of people live in dry lands that are vulnerable to land degradation. Protecting these regions is not simply an environmental issue. It is essential for food security, biodiversity, water resources, and sustainable development. Around the world, scientists, engineers, and local communities are working together to combat desertification. One of the largest environmental restoration efforts is Africa's Great Green Wall Initiative. Stretching across the Sahel region, this ambitious project aims to restore degraded landscapes through reforestation, sustainable agriculture, and improved land management. Rather than creating one continuous wall of trees, the initiative focuses on restoring healthy ecosystems while improving the livelihoods of local communities. Modern technology is also transforming desert research. Earth-observing satellites continuously monitor vegetation, soil moisture, rainfall patterns, and the movement of sand dunes. Using remote sensing, scientists can detect subtle environmental changes that would have been impossible to observe only a few decades ago. Artificial intelligence is increasingly helping researchers predict droughts, monitor ecosystem health, and identify areas most vulnerable to land degradation. Deserts have also become essential laboratories for space exploration. The dry valleys of Antarctica, the Atacama Desert in Chile, and portions of the Mojave Desert in the United States possess environmental conditions that resemble certain regions of Mars. NASA and the European Space Agency regularly test robotic vehicles, scientific instruments, and astronaut equipment. In these harsh environments before launching missions into space, microorganisms discovered beneath desert rocks have expanded our understanding of where life can exist. These discoveries influenced the search for life beyond Earth. If microscopic organisms can survive beneath the scorching rocks of the Atacama or within the frozen soils of Antarctica, perhaps similar life could exist elsewhere. In our solar system, deserts also play an important role in Earth's climate system. Every year, millions of tons of mineral dust are carried by the wind from the Sahara Desert across the Atlantic Ocean. This dust may appear insignificant, yet it performs remarkable ecological functions. It delivers phosphorus and other nutrients to the Amazon rainforest, helping sustain one of the world's richest ecosystems. It also influences cloud formation, ocean productivity, and even hurricane development over the Atlantic. In this way, the Sahara affects environments located thousands of kilometers away. Everything on Earth is connected. Far from being isolated landscapes, deserts interact continuously with forests, oceans, mountains, rivers, and the atmosphere. They influence weather patterns. They shape biodiversity. They preserve history. They support unique cultures that have adapted to some of the planet's harshest environments. Perhaps the greatest lesson deserts teach us is resilience. Life does not simply survive in deserts. It evolves. Plants develop roots that reach astonishing depths. Animals become masters of water conservation. People learn to read the stars, harvest scarce resources, and thrive where others see only emptiness. Nature demonstrates that survival depends not upon abundance, but upon adaptation. As our planet continues to change, deserts will remain among the most important places for scientific discovery. They hold clues to Earth's ancient climates. They help us understand biodiversity under extreme conditions. They guide the search for life beyond our planet. And they remind us that even the most seemingly barren landscapes are full of complexity, beauty, and life. From the endless white silence of Antarctica to the towering dunes of the Namib, from the ancient caravan routes of the Sahara to the windswept plains of the Gobi, the deserts of our world tell a story that spans millions of years. It is a story of geology and climate, of evolution and survival, of exploration and discovery. Above all, it is a story of Earth's extraordinary ability to create life in even the most challenging environments imaginable. The next time you look across a vast desert landscape, remember that beneath every grain of sand, every salt flat, every rocky plateau, and every frozen valley lies a chapter of our planet's history waiting to be understood. Deserts are not empty. They are among the greatest archives of Earth's past, and perhaps one of the most important guides to humanity's future. Thank you for joining us on this journey across the deserts of the world. Until our next exploration of Earth's natural and cultural wonders.